Hi Rockridge, this is Mrs. Berger, and today we're going to talk about function operations and composition. And these two things are going to be talked about with respect to the algebra today. Next day we're going to talk about the graphical operations and composition. So before we do the operations like addition, subtraction, multiplication, and division, we need to talk about something specific to the domain. So up to this point, you've been listing the domain of continuous functions that go on, and you tell us when the domain starts and when the domain stops, and you tell me all of the x values along this function are between here and here. So the domain of function, of course, is all x values on the function. But sometimes we are faced with functions, especially in the algebra that we'll be looking at, that have some limitations to that domain. They have holes, or they have, they have something called asymptotes where they go up to the point and then they pause and they pick back up on the other side. Or they only exist on one side and not over here on the other side. Okay, so we're going to need to account for these limitations in the domain. And we identify those limitations in the domain by looking at the algebra. Now, the two rules that we're going to be looking at are the following. We can't take the square root of a negative, and we can't divide by 0. So those two things are our limitations because functions are in the real number system. And remember, square roots of negatives are imaginary numbers, so functions are in the real number system. So we need to think about what am I not allowed to do in the real number system. Square roots of negatives are no-nos, and dividing by 0 are no-nos. If you can cause that to happen, if there's an input of x, if there's something that x can be that will cause square root of a negative or division by 0, we need to say the domain can't have that in the domain. All right. So let's look first at question number 1. We have a function called f of x, and f of x is x squared plus 3x. So is there any risk, is there any value of x that will cause square root of a negative or division by 0? And if you think about this for a moment, the answer to that question is no. There's nowhere in this function that you could put something in for x and cause a problem with division by 0 or square root of a negative. So therefore, the domain of this is everything, right? X is all real numbers. Or you can say it in interval notation, negative infinity to infinity. X can be anything, right? Question number 2, however, there is a possible square root of a negative, right? There are values of x that you will have the square root of a negative number. If x was negative 1, we would have the square root of a negative number. If x was negative 347, that value of x will cause a no-no. It causes the square root of a negative. So we need to account for that. We need to say that x must be greater than or equal to 0. In order for us to avoid this problem here of division by 0, in order to avoid this problem of the square root of a negative, we have to have x greater than or equal to 0. We can take square root of 0, we just can't take square root of something less than 0. So we can say the domain of this is x such that x is greater than 0, or we can put it in interval notation and say that x can be anything from 0 to infinity. Those are saying the same thing. Let's take a look at number 3 and notice that the problem that could possibly be caused in number 3, we don't have any possibility of division by 0. That's not possible in this particular example, but we once again have the possibility of having the square root of a negative. Now it's a little bit different here, it's a little less straightforward. We can't just say x has to be greater than 0 because that's not the scenario. This entire thing has to be greater than or equal to 0, right? Everything under that radical has to be greater than or equal to 0. X plus 2 has to be greater than or equal to 0 to keep us in the domain of all real numbers. Well, I didn't ask what x plus 2 has to be, I asked what x has to be. So x has to be greater than or equal to negative 2. I subtracted 2 from both sides. So the domain is such that x is greater than or equal to 2, or you can state the domain as negative 2 to infinity. And if you don't believe me, or if you don't believe yourself as you're working through these, try putting numbers in. Does negative 2 work? If you were to put negative 2 in, negative 2 plus 2 is 0, and the square root of 0 is fine. if you were to put in -1, -1 plus 2 is 1, and the square root of 1 is fine. But if you were to put something on the other side of -2, like -3, -3 plus 2 is -1, and the square root of -1 is an imaginary number. So that's how we've just proven that we have correctly stated the domain. And finally, on question number 4, we don't have the square root of a negative problem in this scenario, but we do possibly have division by 0. So we may not have division by 0. That expression on the bottom cannot equal 0. That's a no-no. That whole thing cannot equal 0. So x cannot equal 3. So we can say the domain is x such that x does not equal 3. Or we can say the domain is everything from -infinity up to 3 and 3 to infinity. This union sign basically means that I can have everything in the entire number system except 3. I go up to 3 but don't include it. I go after 3 but don't include it. So both of those domain statements say the same thing. And if you want to check and make sure that we've done this correctly, if you put 3 in for x, 3 minus 3 is 0, and that's a big no-no. But if you have something less than 3, like a 2, 2 minus 3 is -1, and having a negative on the bottom is not a problem. If you put something bigger than 3, like a 4, 4 minus 3 is 1, and 4 divided by 1, that's never a problem, right? Something divided by a positive. So only the actual number 3 is a problem here, and that's why we need to exclude it from our domain. Let's take a look at another couple. Think to yourself about number 5. What rule can we possibly break? Again, the two rules we need to check for are square root of a negative or dividing by 0. Which of those two rules could we possibly break? Hopefully you said the square root of a negative is the rule that we need to avoid. And to avoid that, to make sure that this is always positive and not negative, we're going to say this has to be greater than or equal to 0. Solve for x like you would any other time. Remember, dividing by a negative to get that x isolated means you flip the direction of the inequality. So the domain of this can be stated less than or equal to 3, or you can put it in interval notation, everything from -infinity up to 3 and including it. And if you check numbers less than 3, those will be fine. If you check numbers greater than 3, you'll notice that those are not fine. If you need to pause the video and prove that to yourself, please do so. Let's move to number 6. What rule could we possibly break out of our two no-no rules? Which one can we break with number 6? Hopefully you think to yourself, division by 0 is the problem. How do we solve that problem, or how do we state domains for that problem? We say 2x plus 12 cannot equal 0. It can be less than 0, it can be greater than 0, it just cannot be equal to 0 for this particular one. Let's isolate that. Oh, sorry. Cannot equal -6. So you could declare the domain this way, in set notation, or you can declare it with interval notation. We can take the interval all the way up to -6, and then unify on the other side everything after -6, but not actually -6. And if you need to pause and prove that to yourself by checking -6, a number less than -6, and a number greater than -6, please pause the video and do so. Let's move on to function operations. Function operations, adding, subtracting, multiplying, and dividing multiple functions, works just the same as you would expect it. If you're going to add f plus g, you're literally going to replace f of x with what it is, and add g of x with what it is. It's as easy as you had hoped. So 2x cubed and -6x cubed, those are like terms that we can combine to say -4x cubed is the simplified version of this. Now, we are also asked to state the domain of this. Can we possibly break the square root of a negative or division by 0? Hopefully you thought to yourself, no, there's nothing I can do to break any of those rules. So my domain is everything from -infinity to infinity, or all real numbers. Let's take a look at number 8. Again, we're going to replace f of x with what it is, and subtract g of x. Be careful, because there's a double negative here. So 2x cubed minus a -6x cubed, that's 2x cubed plus 6x cubed, so that's 8 total x cubed. Can't get any simpler than that. When we check for our domain, we check both of our no-no problems here. and there's no possible way that any value of x would cause the square root of a negative or a division by 0. So once again, we can declare our domain as everything from negative infinity to infinity. Now multiplying, once again, it's as easy as you had thought. We take f of x, which is 2x cubed, and multiply it with g of x, which is negative 6x cubed. Notice we're multiplying, not adding or subtracting. So we need to multiply those coefficients to make a negative 12. And we need to multiply x cubed times x cubed, which is x to the 6th. Hopefully you remember your power rules from our earlier units. Once again, for a domain check, we will check and see if there's a possibility of taking the square root of a negative or dividing by 0. Any of that happening here? No, there's no possible way that I'll do either of those. So once again, I can declare my domain as everything from negative infinity to infinity. Now, there's a little bit of a trick to number 10. The division part is not much of a trick, right? It's exactly what we expected. We put f of x where f of x is on the top, and we divide g of x on the bottom, just as we had expected. Now we're going to simplify this as much as possible. We're going to simplify the 2 and the 6. We see that there's a common factor of 2 in both of those. I'm going to stretch this out. You'll see why in a minute. And then x cubed over x cubed, that can be simplified as well, so that I'm left with negative 1 over 3 as my final simplified answer for number 10. But my domain statement is a little bit trickier. My domain statement, though when you look at this, there's no x in there, so there's no possibility of dividing by 0 or taking the square root of a negative in the final answer. However, during solving, if x had been 0 here, we would have had a problem, right? We would have had a problem. We would have been dividing by 0. So x could not be 0 at that point. So even though at the end it looked like our domain could have been all real numbers, in the middle of solving we would have been dividing by 0, and that would have been a problem. So we need to declare our domain, I'll put it in interval notation just to practice that, is everything up to 0 but not including it. Or domain is x such that x does not equal 0. Okay, so be super careful about those on your homework and on your quizzes and tests. Anytime during solving, if you're dividing by 0 or taking the square root of a negative, you need to account for that in your domain limitations. Now, composition of functions is a little more tricky. Composition of functions is also mistaken as multiplication because it kind of does look like it, but please don't get that confused. F of g of x is not the same as f of x times g of x. So keep in mind that that is not the same notation. F of x times g of x looks different than f of g of x. Now the way this works is f of g of x, just like when you said f of 0, let's think about what that was. Let's pretend like we're looking at f of x here. If you were asked f of 0, remember what you did. You replaced the variable x with 0, with the input, and then you evaluated. Well, now instead of inputting 0 into f, we're putting the entire g function into f. So now we're saying when you have an input after 2, you're not putting a 0 in there, you're putting the entire g function into there as your input. Okay? If you need to pause and stare at that for a minute, please do so. You are inputting the entire g function into the f function. That's what that nomenclature right here means. That's what this notation here means. You're taking the entire g function and putting it into the f function. After this point, you simply simplify as you have in past classes, as much as you can, so that the most simplified version of f of g of x is 6x, and it's fine that we have variables in our final. Now let's go in the other direction. We can also put f of x into the g of x function. So just like we did before, we're going to input the f function into the g function. We're going to take the entire f function and input it into the g function where there's a variable. So we're going to say 3 times the entire f function, 2x plus 2. So that means 6x plus 6 minus 1, or 6x plus 5. If you need to pause and look at that, please do so. Alright, let's take a look at question 12, which has different functions. Once again, for part A, we're taking the g function and putting it into the f function. So if the f function is 3 over x, and x in this case is the entire g function, we're inputting the g function into the f function. This is what the final is for f of g of x. There's really not much you can do to simplify this. This is what it is. Now, once again, we are being asked to state the domain. So are there any limitations, if this is my final answer, are there any limitations on the domain? Remember, our problem children were square roots of negatives and division by 0. Now, for part A, there's no chance of taking the square root of a negative, but there is a chance of dividing by 0. So we must not have a 0 on there. That's our big no-no. 2x minus 1 cannot equal 0. Therefore, 2x cannot equal 1, and x cannot equal a half. So you can just state your domain as x such that x does not equal a half. Or you can do interval notation. Now, part B asks us to go in the other direction. We're going to take f of x and put it into g of x. We're going to take f of x and input it into g of x. We're going to take the f function and put it into the g function. This one simplified can be 6 over x minus 1. We'd love to put these into one single fraction, so we can turn this into 6 over x minus x over x, or 6 minus x over x, so that we can have a single fraction simplified. What rule can we break? Hopefully you see that x cannot be 0. X cannot be 0. We can't be dividing by 0, but there's no chance of taking the square root of a negative, so that's the final on that. Now, C looks a little funky, a little strange. We're taking f and putting it into itself, so it's like an inception type of thing. We're going to take f and put it into itself. No big deal, right? F of x is simply 3 over x, right? And since our input goes on the bottom of this fraction, our input is f of x itself. I know this looks a little odd. Take your time, take a look at that, pause the video if you need to. To simplify this, we think of this as 3 over 1 divided by 3 over x. Remember that if you have a fraction divided by a fraction, you can multiply by the reciprocal. And to simplify this, we're left with x over 1, or just x. Now, once again, notice that in the middle of solving this, we could have been dividing by 0. So we need to account for that by saying x cannot be equal to 0 because of that step right here in the solving. G of x is another inception-looking problem. If you need to, go ahead and pause the video and try it for yourself. Otherwise, you can follow along. Let's make ourselves a little skeleton here. So the g of x function looks like this. And we need to input the g of x function inside here, so we will put that function in there. So that means 4x minus 2 minus 1, or 4x minus 3 is our final on that one. And if we look all throughout the solving of this and the final answer, our domain doesn't have to be any limitations. You can say it's all real numbers, or you can say it's negative infinity to infinity. Now, for E and F, your inside value is not an x, it's not a variable, and so we don't have to worry about domain limitations because our domain on these is told to us. The domain of this is 1, so we're going to take that 1 and put it into the g function, and then we're going to take that answer and put it in the f function. We work inside out. Now, my preference for this is to do this into 2 steps. First, I like to find the inside, g of 1, and once I find that, I'm going to take that and put it into the f function. So follow along with me on this one, and then if you are a person who likes to do it all in one step, we will do that as well in a minute. So first I want to evaluate g at an input of 1. We've done this before, right? That, of course, is 1. Now that I've determined that g of 1 is 1, I can replace this with the number 1 and find f of 1. That means putting 1 in where x was. So the final of this is 3. If you would like to do this all in one step, which I know some students prefer to do, let me show you how you would do it. You would take the f function, which is 3 over x, and for x, you would take g of 1 and put it down there, so you would say 2 of 1 minus 1. So I know some students like to do this all in one step instead of breaking it out, and that's totally fine. That would be 3 over 2 minus 1, which is 3 over 1, which is, of course, 3, the same thing we got when we did it in 2 steps. Either one is fine with me. I tend to like to break it out just because I make mistakes when I try to do things all at once, but if you need to do it all in one step, that's completely fine. I'm going to reset the page for a minute because I need a little bit more room for part F. So once again, we have part F as a multiple step function. I'm going to do this in multiple steps. If you would like to do this all in one step, please do so on your own, but I'm going to do it in multiple steps. I'm going to start with the inside, g of 2, and evaluate that. That's inputting 2 into the g function. Then I'm going to work out what f of that input is. F of the 3 is, the f function is 3 over the input, which of course is just 3 over 3 is 1. Then I'm going to look at the outermost and find g of 1. The g function says I need to take the input and multiply it by 2, and then subtract 1 from it. And of course 2 minus 1 is 1. If you needed to do that all in one step, that's fine. If you need to pause the video and take a look at how we did that, that's certainly fine as well. Make sure that you work inside out on these, and by the time you get to the outside, you'll have your final answer. We don't need to declare domains on these because, like I said, the inside number is your domain, that's your input. Alright, go ahead and try your homework and let us know if you have questions.